Okay, the last complication that we're going to talk about here is something called transition metals. And the transition metals are your D and F sublevels on the periodic table, which means these are the elements that their last electrons end up here. These elements here. Right, this block of 10, these are called the transition metals, and this block of 14, which would go here, these are your inner transition metals, so just transition metals. We're just going to call. So these can cause problems because usually S electron and P electrons are on the outer edge. That's the rule that we've learned. But occasionally D and F electrons can wiggle their way up to the outer edge, and that messes with how many electrons can get knocked off or gained. And so what you find is this. You find that metals in these regions can have multiple ionic charges. Sometimes they're 2+. In another situation, they'll be 3+, because there was an extra electron that got lost. Where did that extra electron come from? D sublevels, F sublevels. They are, as far as I know, all positive ions. And it's hit or miss which ones do this. So that there's no rhyme or reason, it would seem, to know which one's going to be what charge. So how are you supposed to know you're dealing with one of these metals that could have multiple charges? Well, here's how this is solved. It's in the name. We have to tell you in the name which ion you're dealing with. So for example, copper is a really good representative of this. Copper can be 2+. In fact, a lot of times, normally it is 2+, but copper can also be 1+. Go figure. So if I were to tell you, hey, let's talk about copper fluoride. Well, and I want you to make a formula for that and do percentage composition. Couldn't do it. You couldn't do it because you wouldn't know which copper I'm dealing with. Yeah, so it's ambiguous. So what I've got to do is I've got to tell you in the name which copper I'm dealing with, and the way this is done is the name of this ion has in it a set of parentheses with a Roman numeral inside. I told you that parentheses were used for other reasons besides more than one of these polyatomic ions, and here's one of those areas. There's yet other places where parentheses will pop in, and we'll deal with those later. But for now, this is the official name of that ion. You would pronounce this as copper 2. You don't say copper parenthesis Roman numeral 2 or parenthesis. You don't do that. It's just, this is the copper 2 ion, and this is the copper 1 ion. So if I want you to make a formula and then do a percentage composition, I have to tell you, it's my responsibility to tell you which copper I'm talking about. So let's just say I did that. Let's talk about this compound. Copper 2 fluoride. We want to make a chemical formula for it. Okay, so what I need to do is, I know this is the positive ion because it comes first. That's the negative ion. What I need to do is look up the symbol and charge for this ion. Well, it's kind of obvious on the charge because it's telling me that it's a 2 positive. But I'll go look anyway, and sure enough, there is a copper 2. Don't confuse it with cobalt. That's CO. Cu, 2+. I can see that right there on the list. And then fluoride, I'd go find that in the negative ion column. home, and that's F minus. And now I'm going to use charge equivalence to write the formula. I've got one negative here and two posits. That is not equivalent. But if I were to have two of these, I would have two negatives, and one of these I would have my two positives. And so the formula would be Cu F2. And then from there I could do a percentage composition. I would say I've got copper, fluorine, and fluorine. Copper is 64 AMUs. Each fluorine is 19. So for a total of, let's see here, that would be 40 minus 2. So if that was 40 and 60, it'd be 100, 104. But I need to take the 2. That's 102. Yeah, I am not planning this, class. So that's 102. It's just kind of uncanny this year. Now, percentage composition wise, the percentage of this copper 2 ion would be 64 of that 102. And the fluorine together, 38 of them, 38 of those AMUs would be the fluorine, and then I could divide these, get my decimal, times it by 100 to get my percents. All right. I guess technically I could just do this one, and then the difference would have to be the other element, so it's even simpler than that. Okay, so now you'll understand when you're going down that positive list why a lot of these ions have parentheses and Roman numerals. It's because they're all these inner transition and transition metals that can take multiple charges, because electrons in those DNF sublevels occasionally wiggle themselves to the top and change things. So, all right, you've got it all that you need for ionic compounds. You get 99.9% of everything you need to know for ionic compounds, you know how to do. So what I should be able to do is throw any ionic compound out here. What I mean by that is any combo of ions on this list. I should be able to randomly pick a positive ion, write the name for that, randomly pick a negative ion, write the name for that, and then have you decode it into a chemical formula and give me a percentage composition. That's the goal. That's the target. The target says I can write a compound's formula and determine its percentage composition by evaluating its name, and you have done that for ionic compounds. Now we still got to do covalent compounds, but we'll do that when I come back. All right? So for now, what you're going to do is you're going to apply these rules to the problem set that is in the survival guide. And you can work together to figure this out, and I have provided solutions so you can check your answers. I'll see you when I get back.